This video demonstrates parallel plate flow chamber analysis for examining the factors that trigger leukocyte rolling on endothelial cell surfaces. Endothelial cell monolayers are stimulated with the pro-inflammatory cytokine IL-1 beta to upregulate E-Selectin expression. The parallel plate flow chamber is then placed over the endothelial cells, and E-Selectin-positive leukocytes are infused over the monolayer. The cellular interactions in the chamber are thus imparted with shear stress that is similar to that in post-capillary venules. Leukocyte adhesion rolling events are captured and enumerated using NIS elements and assayed for E-Selectin dependence.
Hi, I'm George Weiss in the laboratory of Dr. Charles Dimitrov in the Department of Dermatology at Brigham and Women's Hospital, Harvard Medical School. Today we will show you a procedure for analyzing the role of E-Selectin, E-Selectin ligands in the adhesion of human leukocytes to human bone marrow endothelial cells under physiologic blood flow conditions. We use this procedure in our laboratory to study the role of cell surface molecules that initiate the adhesion of white blood cells or metastatic cancer cells to endothelial cells, which line the inner surface of blood vessels. This adhesive event is characterized by a rolling behavior like a bowling ball rolling down a lane. So let's get started.
The first step in this procedure is preparing the endothelial cells that will line the flow chamber. This protocol uses HbMEC60 cells derived from human bone marrow microvasculature. Culture dishes should be pre-coated with fibronectin. To prepare these, incubate 35 milliliter tissue culture dishes with PBS containing 20 micrograms per ml of fibronectin. These may be incubated overnight at 4 degrees Celsius or for 3 hours at 37 degrees Celsius. Suspend HbMEC60 cells in medium 199 and seed at 10 to the 5th cells per dish. Grow the cultures to over 90% confluence. This will take about 2 days. To upregulate E-Selectin expression, aspirate the growth medium and add fresh medium with 50 nanograms per ml of IL-1 beta. Incubate for 4 to 6 hours. Cell monolayers are now ready for the flow chamber assay. Additional plates of HbMEC60 cells can be stimulated with IL-1 beta and treated with neutralizing anti-human E-Selectin antibody at 20 micrograms per ml for 1 hour at 37 degrees Celsius. This will control for functional expression of E-Selectin. Next, prepare the E-Selectin-positive leukocytes. These are Kg1A human hematopoietic progenitor cells. These are grown in suspension to confluence, or 10 to the 6 cells per ml in rPMI 1640. The Kg1A cells may be pipetted directly from the culture and counted on a hemocytometer. Resuspend the cells at 10 to the 6 cells per ml in HBSS with 10 millimolar HEPs, or HH buffer, that contains 2 millimolar calcium chloride. Store the cells on ice until they are assayed. The next steps involve preparing the microscope, the parallel plate flow chamber, and the syringe pump for the assay. Turn on the microscope and the syringe pump. Select the 10x objective on the microscope. Place a 50 milliliter conical tube in the holder and fill it with HH buffer with 2 millimolar calcium chloride. Then place 5 milliliter plastic test tubes in the holder below. Next, put a 60 milliliter syringe in the syringe pump. Make sure that both the plunger and the body of the syringe are secure. Attach a 3-way stopcock to the end of the 60 ml syringe and then a 5 ml syringe to the 3-way stopcock. Place the parallel flow chamber apparatus on the microscope stage with input tube on the right, output tube on the left, and vacuum tube in the back. After the tubing is connected to the vacuum, open the air valve to allow the parallel plate apparatus to adhere to the stage. This will test if the vacuum skirt on the flow chamber is airtight. When the seal is affirmed, turn off the air valve. Now attach the output tubing line to the 3-way stopcock that is already connected to the syringe. The apparatus is now ready to place over the HbMEC60 cells. Turn on the vacuum. Gently lower the flow chamber apparatus onto the plate and allow the apparatus to suction down. There should be no sounds of air escaping, and at this point you may need to apply pressure to the chamber to compress the rubber gasket. Once the vacuum has been established, place the input tube into the 50 milliliter conical tube. Open the three-way stopcock to the 60 ml syringe and place the pump in pump mode. To remove air from the lines without lifting the cells on the plate, use the syringe pump set at 2 ml per minute to fill the intake tube. Then quickly set to 0.5 ml per minute just before the fluid reaches the apparatus. It is critical to prime the setup carefully and avoid air bubbles, which will lift the monolayer from the plate. Once fluid moves into the 60 ml syringe, the flow chamber and the syringe pump is primed. Now secure the flow chamber to the stage with a piece of tape over each of the input, output, and vacuum lines. This ensures that the field of view remains constant when visualizing and collecting the data. The flow chamber is now ready for use. These steps should be repeated for each cell input run and for each new plate. To capture leukocyte rolling events, open NIS Elements on the desktop. Press the play icon for a live image. Auto exposure will allow you to see the plate and to focus the image. Be sure the microscope is focused properly on the cell monolayer by adjusting focus manually on the microscope. Once the image is in focus, reset the exposure to 1 frame per second and adjust the light on the microscope. The image should appear on the computer and should no longer be visible in the microscope. The light histogram can then be adjusted to remove background exposure or to improve cell clarity. Click on 2x2 bin or live bin to obtain an image that is ideal for movie capture. Click on Macro on the menu bar and select Write to Port. Select Port COM3 and open. This opens the port to coordinate with the syringe pump. The flow chamber is now ready to be infused with KG1A cells. Pipette 1 ml of KG1A cell suspension into the 5 ml test tube near the input tubing line. Then place the input line to the bottom of the test tube. Go to the menu bar and click on Capture and Time-Lapse Acquisition. Select the protocol lasting 210 seconds. This is the length of the program for rolling on HbMEC60 cells. Each phase is programmed to take a picture every second for the duration of the pump protocol. It is also set up to send a command through the COM3 port to start the pump. Set the syringe pump to program mode, which allows for manual programming of specific flow rates. This will determine the shear stress levels within the chamber and dictate KG1A cell interactions over the HbMEC60 cells. Settings for these interactions are 4.2 dynes per centimeter squared for 45 seconds, 0.3 dynes per centimeter squared for 60 seconds, and stepwise increases every 15 seconds to a maximum of 4.2 dynes per centimeter squared. The microscope and computer are now ready to capture time-lapse photography. Press Start Run on the computer to begin acquiring data. While running the program, be sure to add media to the tube containing KG1A cells in order to keep the input-output tubing full of medium and to prevent air bubbles from entering the system. If the time lapse is interrupted, the pump will not stop on its own and must be reset. Press Cancel to return to the live image. An unstimulated endothelial cell monolayer serves as the negative control for this experiment. To do this, infuse KG1A leukocytes into the flow chamber over untreated HbMEC60 cells. To control for E-Selectin dependence, stimulate the endothelial cell monolayer with IL-1 beta and infuse the leukocytes over these cells. To further control for E-Selectin dependence, treat HbMEC60 cells with IL-1 beta and then with anti-human E-Selectin antibody. Then analyze leukocyte rolling events on these cells. Cell rolling is not only determined by E-Selectin, but also by sialic acid residues on the leukocyte cell surface. To show this, digest the Kg1A cells with 0.1 units per ml neuraminidase for 1 hour at 37 degrees Celsius. Then analyze the rolling events over stimulated HbMEC60 cells. Glycoproteins on the leukocyte surface are also important for cell rolling. This can be demonstrated by treating the Kg1A cells with 0.2 units per ml bromelain for 1 hour at 37 degrees Celsius, and then infusing them into the flow chamber. After the time sequence is acquired, the data are ready for analysis. Save the data and go to the Measure tab on the menu bar and select Define Threshold. Move the bars so the desired cells are colored in red. Select all images and then OK. The entire time-lapse sequence should now be modified with visible red rolling cells. Go to Measure and select Restrictions. This allows the user to exclude thresholded objects that do not represent rolling cells. These are primarily background created by the HbMEC60 monolayer. Select area and input minimum and maximum values, which are ideal for the rolling leukocytes. Repeat this step for elongation and circularity. Select Measure and then select Create Binary using restrictions. The same restriction values which were set in the previous step will now be used to optimize the NIS Elements software for recognizing rolling leukocytes on the endothelial cell monolayer. Go back to Measure, select Field Data, and then select Reset Data. Close the menu, return to Measure, and select Scan Field. Open Measure, Field Data, and select Number or Objects. Then select all fields and export the data to Microsoft Excel. Finally, select Clear Data. NIS Elements is now ready for more data collection. These representative data show how leukocyte-endothelial cell interactions respond to physiologic shear stress, specifically testing the role of the adhesive ligand E-Selectin. Robust leukocyte rolling occurs when endothelial cells are pre-stimulated with IL-1 beta. When comparing this result with the unstimulated control, it is clear that cell rolling is dependent on cytokine stimulation. By treating the HbMEC60 cells with IL-1 beta and then with anti-human E-Selectin antibody, it becomes clear that the cell rolling depends specifically on E-Selectin. This assay can be used to test other parameters as well. For example, when stimulated cells are pre-treated with a sialidase or with bromelain, the results are less robust. These data highlight the importance of terminal sialic acid residues, as well as cell surface glycoproteins, for E-Selectin ligand activity.
We've just shown you how to analyze E-Selectin-based adhesive interactions between leukocytes and endothelial cells under conditions that mimic forces present in a postcapillary venule, the region of circulation system where leukocytes leave the blood and enter tissues. When doing this procedure, it's important to remember to use the appropriate blocking antibody or enzymatic treatment control to validate the necessity of the respective selectin and its ligand in this assay system. So that's it. Thanks for watching and good luck with your experiments.